Hi, everyone. Hope everyone's doing well, and thanks for tuning in to our presentation on this paper. So, our paper we presented is titled "Brag to Riches," and it's essentially a comprehensive journey through retrieval interlaced with sequence generation. So, we went through this paper, and we're excited to share our findings with you guys here. Um, Alongside myself, Vadiraj and Afia helped work on this together, and Vadiraj will be presenting alongside of me today. The paper. So the approach that they actually detail in this paper. So getting into this, what is riches? So the term itself is actually inspired from the title you saw before. They take certain letters from the overall retrieval interlaced sequence generation, and they essentially combine it to make that nice title you see, "Rag to Riches." So, from a more functional standpoint, riches refers to a technique that integrates retrieval and generation tasks seamlessly, eliminating the need for a separate retriever and generator components. So it effectively streamlines the overall process of a conventional RAG and does it in a pretty fascinating way that we'll get into as follows. So a continuation to the approach, we leverage large language models. But we The approach leverages large language models, but these are, as everyone knows now, central to natural language processing, and they often handle tasks such as sequence-to-sequence transductions. Riches integrates text generation with retrieval within a single LLM and decoding process, effectively eliminating the need for a multi-system pipeline, as I noted previously. So a continuation further, the overall purpose of riches is to remove the need for the separate retriever, generator, and the other components as well, such as the need to unify the retrieval and sequence generation tests into multiple processes and really just blending them together to, as I stated previously, make it more cohesive in that manner. So this enables efficient multi-hop retrieval and thought planning without external retrieval systems. The observations Riches is built on LLMs as knowledge warehouses. LLMs store vast data and generate accurate responses. However, they can hallucinate and lack up-to-date data, making retrieval essential. That's a common notion that we all know is essential to RAG overall, and that's no different here for riches, as it's effectively a method of enhancing what is referred to as conventional RAG. So moving forward, LLM decoding is a search process, and this can be detailed in the sense that they involve searching for the best sequence among all possible ones, and retrieval narrows the search to relevant sequences within a corpus to effectively find useful context based on the corpus. Now, the key component for riches that distinguishes itself from RAG is the unifying retrieval and generation. So combining retrieval with generation in a new task in a single step allows for quick adaptation to new tasks through prompting, allowing for the utilization of instruction-tuned models without. Sorry about that, some technical problems. All right, so now related work overview. So Riches builds upon these related works that are noted in the paper. Essentially in the reasoning that's actually employed. So retrieval-augmented generation, as I noted before, is the conventional method, and essentially open domain question answering tasks are used in RAG, where a dense retriever fetches documents for a language model to generate answers, as again the typical means of actually employing these in practice. Generative retrieval, this shifts search tasks to language models. However, memorization techniques struggle with unseen data. Recitation, language models can recall passages but are prone to hallucination, part of why grounding them in sound evidence via retrieval is so essential. Iterative reasoning and search, recent work has improved multi-hop question answering through improved reasoning and planning while integrating with search within generation. Moving forward to retrieving while generating. with a focus on the ideas and techniques employed in this section. So, with regards to indexing strategies, constrained beam decoding is employed in the Ritchie's. And this is opted as the decoding strategy to simulate a heuristic best first search. They also focus on efficient constraints via the FM index. The FM index helps limit model outputs to what's in the corpus by masking relevant continuations. It achieves this by using a compressed suffix array with extra structure to quickly search substrings. Further in the indexing strategies, they also utilize an adaptive beam size. This effectively ensures that Ritchie's can properly make use of beam search and adaptive decoding strategy an adaptive decoding strategy was introduced that switches between full beam decoding for the sensitive constrained sequences while opting for greedy decoding when unconstrained. So this essentially shows us the adaptive component here, where scenarios where greedy decoding would be more optimal for unconstrained scenarios, it's employed, whereas full beam decoding, when sensitive constrained sequences are more useful, it does that. So it essentially can bounce between which one is more suitable in each scenario there. Now, in addition, it employs various retrieval keys like document titles, paragraph sentences, and propositional index so that retrieving the relevant context can be done effectively. Effective passage search focuses on optimizing the search process by swiftly locating relevant information within a corpus. The contextual passage generation. This feature attempts or aims to generate accurate passages by grounding them in the corpus. This helps prevent hallucinations, which again is the essential or one of many essential components for a conventional RAG and is no different here for Ritchie's. So now this is a specific example of how a decoding process would work based on the breakdown of a specific query. So when did Marathon change its name to Snickers? And it basically shows that as these terms or as the output was generated, it's effectively considering different routes of progressing as it generates the response. And this effectively details how certain responses are deemed as suboptimal and identifying the more suitable response that is, again, more viable given the specific nature of the actual query. So in this example, we follow Marathon. Marathon was renamed Snickers and then 1990. Bold boxes track the progress of the top beam sequence, and the gray boxes cross out sequences that the LLM preferred but were blocked by corpus constraints. So effectively, the LLM itself would have followed the route of the gray boxes, but given the specific implementation of the fact that the response has to be grounded in sound evidence via the corpus, the actual bolded option was what was chosen and is more relevant in this case. So that's a successful example, essentially. So now interleaving, retrieval, and generation. So the term interleaving alongside interlaced, as you saw in the title, both carry immense significance as their usages emphasize how the retrieval and generation processes are effectively woven together. In theory, this allows for a more robust response, which aligns with up-to-date information at a higher capacity than conventional RAG by leveraging said context as generation is ongoing. The result of this is a streamlined workflow where the essential aspects of a typical RAG are enhanced as continuous context is gathered and employed during response production. Moving forward to the experimental setup. So now into the experimental setups. Basically, as I noted before, the open domain question answering tasks are what's focused, and this is often the case for RAG chatbots. Open NQ data is used for single hop, so when the response is to be grounded in a single source of evidence. And then hotspot QA and unique ANS for multi-hop, when multiple sources of evidence have to be gathered together in the production of the response. The corpus that is employed is a Wikipedia corpus presented in botnet, ET, AL dot 2022, used to derive title, passage, and sentence keys. Factoid wiki corpus built by Chen et AL dot 2023 is used for the proposition specific. From an evaluation standpoint, end-to-end answer accuracy with F1, and attribution of answer to evidence with auto AIS. So the F1 evaluates how well the response, how well the generated answer is when compared to what would be deemed as suitable, and auto AIS effectively gauges how well said answer is grounded in concrete evidence. So they work very well together for the specific situation. Continuation in the experimental setup, models and inference instruction, tuned versions of PALM 2-M and PALM 2-L are models that are employed. These are the large language models here. Few shot prompting, 3 examples for different sets, where different sets are employed for single and multi-hop data sets. So effectively integrates them for each of those. Final setup. So they progress with a beam size of 10 with constrained decoding, adaptive beam size, and propositions as retrieval keys. So certain chunks of text would effectively correspond to a certain document that is associated with said text being retrieved as relevant context for that query. Baselines. So no retrieval using unconstrained baseline resulted in hallucination. Single hop QA, generalized dense retriever, and PALM N2, generalized well out of domain, and multi-hop QA, iterative retrieval using GTR and PALM2-M. So these are effectively the benchmarks that are used when actually assessing the performance of the Richies.
Yeah, okay. Let me take you through the results. The results in the table 1 here shows that out of all the retrieval key strategies, the propositional indexing proved to be the best among the others. It could be because of its compact nature that it is most suited for autoregressive decoding. With respect to the beam size, expanding the beam allowed for improved exploration of the search space. We can see this from table 2. Hello. Yeah. And table 3 shows that an adaptive beam is essential for balancing unconstrained and constrained sequences. Using adaptive beam along with the insertion of keywords improves both answer and the retrieval performance. Similar to the chain of thought approach, we can see from table 3 that both accuracy and attribution scores are higher when both keywords and adaptive beam search is used together. The first observation with respect to the overall result is that by combining retrieval with generation, it does not negatively affect model's answering capability that we can see in comparison with no retrieval benchmarking results. For single hop QA tasks, the richest does better than the dense retriever, but with compromised attribution score that we can see from the auto AIS score. For multi-hop QA, the richest excels on both accuracy and attribution for both the data sets of hotspot and the music when compared to dense retrievers. So here, the richest can achieve these results in a single inference pass to the LLMs, unlike the iterative baseline approach where the calls to the LLM models are made for each subquery steps. So another point to note here is that the results get better with respect to the size of the LLMs used. The larger is the LLM, the better is the result. So when we look into some of the strengths and weakness of the richest framework, when compared to the strengths, the richest makes use of the parametric knowledge of the LLMs for the search operations, since the search in riches is independent of the corpus size because it depends on the index structure. Thus, making it possible to employ much larger LLM models at the query time. So another advantage with search using LLMs are that they are naturally good at finding the contextually relevant passages, while the dense retrievers may sometimes just focus too much on the keywords. The riches make sure to override the LLM's existing knowledge by constraining on the corpus, while generating the answers, preventing the LLMs from hallucinations. So having said that, the riches is not all perfect. Sometimes it fails to get desired output on the QA tasks. The table 5 here shows that the one such example where the 50 failed queries on the hotspot QA datasets are analyzed, and the losses are categorized into 3 types. Index failure, where the proposition is not present or decontextualized. The search failure, where the proposition present, but the system failed to generate the answer. And the last one is the attribution failure, where the generated answer is hallucinated and not in terms with the evidence. So let us look into the limitations and the conclusions. So some of the limitations of the experiments are the experiment was heavily relied on Wikipedia content, which is the corpus that is used for pre-training. Also, the study doesn't investigate how riches perform on the data that it hasn't seen before. The evaluation is mostly an experimental than the objective evaluation, hence only few factoid QA tasks were tested. There are other limitations with riches approach itself is that the framework cannot retrieve many documents, which is prerequisite for this summarization task, and also rewriting the long documents with scattered information into contextualized propositions for an indexed strategy is complex and also a cumbersome task. So to conclude, the research showed how we can seamlessly integrate the retrieval with the generation during single decoding pass to LLMs. Various indexing and decoding strategies are considered for an effective solution, and the results are evaluated against dense retrieval systems for various single and multi-hop QA tasks. The results show that the riches could improve traditional architecture in certain situations, and by unifying retrieval with generation allows us to adapt to diverse new tasks via the prompting alone without any need for an explicit retrieval system. So with that, we conclude the presentation. So the more information regarding the paper can be seen in this link here. And if you have any questions, we are open for that.